Let u and v be from Rn. The dot product of u and v, and is denoted by u dot v, is defined to be the quantity u1 times v1 plus u2 times v2 plus all the way to un times vn. For example, if u is 1, 2, 3, and v is 4, 5, 6, then u dot v is 1 times 4 plus 2 times 5 plus 3 times 6, and that's 4 plus 10 plus 18, and that's 32. Notice that this dot notation is overloaded because it is also used for multiplication in a field. As confusing as it might be, the context will usually make it clear which is intended. We say that u and v are orthogonal if u dot v is 0. You can think of being orthogonal means being perpendicular. When n is 2 or n is 3, if neither u nor v is the zero tuple, then the dot product of u and v is 0 if and only if the arrows representing u and v form a right angle. In fact, a little bit more can be said. Say we let theta denote the angle between u and v. Here's a picture illustrating what this means. Say u is this and v is that. Theta is the value of this angle here. Then cosine of theta is equal to u dot v divided by the square root of u dot u times the square root of v dot v. So this formula is true for n equals 2 and n equals 3. So in three-dimensional space, if you measure the angle theta, then the cosine of that theta is given by this expression here. And you can see cosine theta is 0 if and only if u dot v is 0. Of course, we are assuming here that neither u nor v is the zero tuple. And cosine theta is 0 if and only if theta is pi over 2 radians, which is the measure of a right angle. Notice that the way we define theta, its value is always between 0 and pi. And one often writes this for the square root of u dot u. And when n is 2 or n is 3, this quantity gives the length of the arrow representing u. For general n, this is called the norm of u. So this is the quantity, the square root of u1 square plus u2 square and so on plus un square. And a vector having norm 1 is called a unit vector. Let us now look at a couple of examples. Suppose u is 2, 0 and v is 0, minus 1. If you look at u dot v, I have 2 times 0 plus 0 times minus 1. And that is just 0 plus 0, which is 0. Now the norm of u in this case is going to be the square root of 2 square plus 0 square, which is just 2. And the norm of v is the square root of 0 square plus minus 1 squared, and that's 1. Let's look at another example. Let's say u is 3, 3, and v is 0, 2. I'm not going to draw these vectors, and I'm just going to calculate the cosine of the angle between them. So cosine theta is going to be given by u dot v divided by the norm of u times the norm of v. And u dot v is 3 times 0 plus 3 times 2. And that is divided by the norm of u, which is the square of 18. And the norm of v, which is the square of 4. And so this is 6 divided by 3 times square root of 2 times 2. And that is 1 over the square root of 2. And this is the cosine of a special angle. And in fact, theta has to be pi over 4. Or in degrees, it will be 45 degrees. If you draw U and V on the plane, you'll see that they do indeed form a 45-degree angle.